Hello folks. So in the last video we discussed a bit about reverse proxy. If you can remember, then we also went a bit into load balancing and stuff. So I thought like it might be a good idea to dive a bit deeper into the load balancing aspect of it, since that's something that we like. If you're into backend development and stuff, you will be facing that very frequently. So I thought it would be a very it would be a good thing to know, like dive a bit deeper into it from the networking aspect and the development aspect of it. So yeah. So in the last, for a quick refresher, what we discussed was we were talking about reverse proxy in the last video. If you can remember, I'll just link it somewhere around here if you want to watch it again. So we were discussing about reverse proxy, and one thing that someone needs to keep in mind is like load balancer is an application of reverse proxy, but it's not like you cannot tell every load balancer to be a reverse proxy or that sort of thing. Basically, sorry, I said it wrong. So basically, what the thing is, every load balancer is a reverse proxy, but every reverse proxy need not be a load balancer. So that's what I wanted to say. So load balancer is like an application of reverse proxy where you can use it. So basically, the basic concept of reverse proxy is multiple devices or entities would be represented by a single one. What forward proxy meant was it will make a request on your behalf, like the router thing that we discussed, similar to that. Like there are multiple devices in a network, if you assume, then if you want to talk to someone from the public network, you have to go through the router. So that router will impersonate your device, and it will make the request on your behalf, and it will get the response, and it will send it to like whichever device it is intended. That like we discussed. So reverse proxy does the opposite. You make the request to the reverse proxy. It will make your request there will be it's the opposite of it. Basically, you make the request to it directly, and for forward proxy we used to make the request through it. So that's the difference. So load balancing is like an application of reverse proxy, like we discussed. So in load balancing, what happens is, let me just copy this. So we have different entities of the server running on the backend, like so that it's highly available. That's the basic part of it. Like the purpose of load balancing is, of course, like if one server goes down, the others can take care of it until that comes up. And also, like if one server takes a very high amount of load or traffic, it can be distributed among all of them properly. So yeah, those were some reasons that we go for load balancing, as the name suggests, so that we can make the system more and more fault tolerant, if that makes sense. So yeah, this is the basic aspect or the basic idea of load balancing that we discussed in the last video. Now let's two things that I wanted to talk about was like how can we load balance, like what are the types of load balancing and stuff, which is a very common thing that you'll find like it goes around everywhere in a tech community. Like there are numerous Cloudflare blogs and stuff on it, and so yeah, you can check those out as well. I'll add the link somewhere and we'll come to that. But basically, primarily there are two types of load balancing. One is layer 4 load balancing, and another is layer 7 load balancing. If I can type. Okay, so these are the two types of load balancing: layer 4, layer 7. If you can remember, it comes from the OSI model. Like we had layer 4, layer 7. Layer 7 was the application layer, layer 4 was the transport layer. So if you can remember that, basically that should do it. So layer 4 deals with ports, like we discussed, and layer 7 is the application level. Like basically it goes abstraction and everything, and like on the top of it we have the application. So yeah, so let's start with layer 4 load balancing first, and maybe then we can move to layer 7. So layer 4 load balancing, how do we do it, and what's the significance of it and stuff. So yeah, what happens is, like if you can imagine, if you imagine this whole thing to be one single entity, let's say this whole thing is an entity, and load balance sorry about that. Load balancing is like the entry point for this, since it will have some IP and we make the request to that. So let's say it's something like x dot 1. This x can be like anything, like 444.333 anything. So here we have, let's say x dot 2, x dot 3, and x dot 4. Okay, so let's say these are the servers, this is the load balancer, and this is you making the request to the load balancer. So you are making it from, let's say, x dot 5 maybe. So let's say you're making the request to the load balancer. Works? Okay, so you send some data. Now what will happen after that? So the load balancer, like we discussed, its responsibility is to redirect or send the data, like whatever you have sent, to the servers and get the data back and send it back to you. So in layer 4, what happens is, like since it's directly on ports, it won't need what it won't detect what protocol are you using, what data are you sending, and all. It will just check the check the source, check the destination, and like route the data somewhere. So basically, also another thing, before this connection, what load balancer in layer 4 does is it will establish connections to the servers before itself and keep them open since in ACK, like we discussed, because establishing connections are also expensive. Like if you remember, we had a 3-way handshake. These are separate TCP connections, of course, like that I forgot to mention. So like this is a TCP connection. These are same TCP connections that are going from a load balancer to like the other addresses and stuff. We'll come to this. Like I forgot this aspect, so I'll just explain it before. So just so that it could redirect a request and anything, it will establish connections with the server and keep them open. And whenever it needs to route some traffic, it will send it to the server. It will get the response back and send it back to the device. It's you. So that is the basic thing. So let's start from the beginning. At the beginning, the load balancer will establish separate TCP connections with the servers or the devices that are inside, inside their network, and it will keep them open so that we don't have to pay the cost for the SYN-ACK ACK, like SYN-ACK ACK again and again. Like that also encompasses some cost, like the connection establishment thing, and it's like an optimization step to ensure that we don't have to create new connections again and again, and we can maintain the connections throughout. So yeah, and now what happens is, let's say you make some request to the load balancer. Load balancer has these 3 TCP connections open. It will send it to one of them. It will get a response and it will send it to you back. But there are some aspects to that as well, of course. So what we discussed in the NAT table, if you can remember, what load balancing in layer 4 would do is, see, basically it will come from x dot 5, right? So we have x dot 5. We are sending it to x dot 1. This is the IP packet, let's say, or segment, sorry, I mean not packet, my bad. And we have the data here. Cool. So source, destination, data, that's all. We send it to this, but what this will do is it will store it. Let's say if we take the NAT table, for example, we can that is also used for layer 4 load balancing. Like you can use a NAT table to make the router behave like a layer 4 load balancer. We will see that now. So basically what it would do is, let's say it put first of all it would get the data, it won't read it. It will just redirect it to say x2. It sends another packet to it, of course, like because it's an why I keep saying packets. It's a segment. Sorry, it will keep it will send another segment to like from its own connection. It will have a source of x dot x dot x dot 1 and a destination of x dot x dot x dot 2. If that makes sense. So, but one thing that you might have noticed here is the subsequent segments that will come after it, those will also go to this device for this connection, because for this particular connection, load balancer sort of hard. This layer 4 load balancer sort of hard codes that any segment that comes from x dot x dot x dot 5 send it to x dot x dot x dot 2. Like, let's say this is data for segment 1. Okay, this is data for segment 1. If data for segment 2 also is sent, let's say, that will also be sent to this S1 only, since it's already noted inside that for this particular connection, send everything to this one. That's a drawback, because let's say there are multiple connections that are established with a load balancer and multiple TCP connections open. There is a scope of like not uniform distribution of load across the devices, because until let's say this connection is established already and these are talking to and fro with each other, but suddenly like the S1 faces a huge amount of load. This is not like this is not smart enough to do something about it. Like, let's say, what do you expect in such a situation? What's the purpose of load balancing is? Like, let's say S1 is facing a huge number of traffic or requests or something, then ideally what you should do is you should send it to some other server. But until this connection is closed, for the same connection, it will send it to the same server or the same device. Even if like the distribution, like I said, the distribution of load might be an issue with this, as you can see. Let's say we make a new connection, and then it's possible for it to assign it to other device, but for the same connection, it will always send the data to the same device. Since it's sort of hard-coded on the load balancer side, that if this is the source, send data to this, that's all. And if data comes from this, then send it to this, like we discussed in the net table, sorry. So here, if you can imagine, let's say if data comes from x1, x dot 1, send it to x dot 2, and if data comes from x dot 2, send it to x dot 1. That's the record. So if you can imagine this is like a one connection, like on a very top level. Of course there are two connections, but this is a very like hard-coded sort of a connection. There is no dynamic aspect to it. The only thing you can close this whole connection is if you make a new connection from your side to the load balancer, then it might make a new connection with some other device, but this is fixed throughout the whole like communication aspect of this particular connection, if that makes sense. So that's a disadvantage that we have in layer 4 load balancing. But this is somewhat solved by a cloud. This is somewhat solved by Cloudflare in like the way they handle it. It's called Unimog. I think they wrote a blog about it. I'll link it in the description. If anyone wants to read it, you can go ahead and read it. Like, they beautifully have a way of smartly load balancing the stuff for a layer 4 load balancer. But yeah, in general, this is the case. So data S1, data S2. That's what. Now let's try to take a new example, like how the whole transmission would take place. Like, now that we are done with the concept of it, let's try to dive a bit deeper. So we don't need this as of now. Let's say it's making some TCP request. It has established the connection with the load balancer, let's say, and we don't these are established, but we are just talking about this connection as of now. They have already like TCP connections established from before, so that they can avoid the SYNAC again and again, like we discussed, of course. But let's say for this connection, the load balancer says that for x dot x dot x dot 1, send the traffic to x dot x dot x dot 2. I mean, no, sorry, I typed it wrong. For x dot x dot x dot 5, if any request comes from x dot x dot x dot 5, send it to x dot x dot x dot 2. So this is like one way hard-coded path sort of a thing that's established. So let's say this is established. Let's say while we send one segment S1, when we send S1, it will go to the load balancer. The load balancer will check where to send it. It will send it there. Then let's say we send S2, it will do the same thing again. It will send it here itself to the same device. You will get the response, it will pass it back. So now let's say we are done. We close the connection. We made a new like this connection is closed now. This connection is closed now, and this is done. So the initial part is done. Connection is closed. Now let's say I'll keep them on the side for now. Now let's say we make another connection to the same load balancer. Let's say for another request or something. Now like it will do the same thing, but maybe for another server. Like let's say any request that comes from this should go to x dot x dot x dot 4. So it will like hard code that sort of a connection between these two devices. Oh, sorry. So it will hard code that sort of a thing between these two devices, and if we send segment 1 and segment 2 from here, it will go to here. Another thing that one needs to keep in mind is we cannot while one connection is going on, like what we do is we divide the data into segments, of course. So one thing that we need to keep in mind is we cannot send one segment to this, another segment to this, because like we said, segments are basically data broken down into fragments, and then we try to send them so that we are not sending a huge payload at once. We break it down, we send it, and then the destination will arrange them in the sequence so that it can read the data in the format that it's intended to. But if we send one segment to this, one segment to this, one segment to this, that won't make any sense. Like that's just wastage of bandwidth and stuff. Everyone will send like reset the connection, I'm not able to read this, and like it will again retransmit and everything like we discussed. So that's just extra overhead on our side. So one thing that you need to keep in mind is these segments needs to go to the single device, of course, finally, so that it can be decrypted on that side and response can be sent in that format. So yeah, that's layer 4 load balancer for you. One disadvantage, like we discussed, is it's not like very smart with the load balancing aspect of it, and like it keeps the connection very like hard coded sort of a thing. Like this, any request that comes from this will have to go to this. So if you assume like maybe this is a DDoS server or something, so it's making a huge number of requests at once, and it will receive a huge number of load. So by this mechanism, like it has the capability of to take the server down. Like we cannot call it DDoS because it's coming from a single source, of course, but let's say that's one possibility. Like one server can be overloaded with requests while the others can be like chilling and stuff. So the uniform load distribution can be an issue here. And yeah, that's all for layer 4 load balancing. I hope this was helpful. There is, I think it's already very long, so layer 7 I'll make a separate video about it, I think. So yeah, if anything, like if you like the video, you can like, comment, subscribe, and maybe share it to your friends. And of course, if you have some confusions and stuff, you can always ask in the comment section. And yeah, see you guys, bye.